To start, we can look at a simple shape pattern and see how it grows. So if we look at this table, we'll call it a table of values. T is the frame. So for example, when T is 1, it matches here. T is 2, it matches here. T is 3, it matches here. And 4 matches here. So to make a table of values, we have T, and then the output is the total number of squares. So for example, if we look at the first frame, there are 2 squares. Okay? If we look at the second frame, there are 4 squares. Okay, I know I'm writing big. If we look at the third frame, there are 6 squares. And if we look at the fourth frame, there are 8 squares. Now my writing turns to typing, so it's a little bit easier to see that the numbers are a little bit smaller, and how when T is 1, the output is 2. When T is 2, the output is 4. 3 is 6, and so on. Now, when you have a table of values, you don't really need the shape pattern anymore, because you need to find a relationship between T and the output. So what is the relationship between 1 and 2, or 2 and 4? I'll give you a minute to think about it. Now, if you said that you take the value of T and you multiply it by 2 to get the output, you would be correct. Often in algebra, when you have something that's like T times 2, it might also be written like this. And you have to be aware of that, so that T times 2, or 2T, would give you the output. Whether you write T times 2 or 2T, it doesn't really make a difference. So this would be called the pattern rule. And with this pattern rule, we can predict any input-output value, because you're not going to extend the table of values all the way to 10 or the 20th term. That wouldn't be very efficient. So T times 2, well, we can look at the 10th term. So the 10th term would equal 10, because that's the 10th term, so I'm substituting T for 10 times 2. And we know that 10 times 2 is 20. Okay? Notice how my equal sign, when I'm writing multiple equal signs, how they line up. Okay? It makes it much easier to read and is proper. In looking at shape patterns and algebraic equations, sometimes it's useful to look at the shape pattern and see what's really being added. In the first frame here, really nothing is being added. So we can say that the first frame is really T plus 0. Now, if we look at the second frame, okay, I put different color squares, and that helps you to see that something is being added. And we can see that 2 squares are being added. So for the second one, we can also say that it's 2 plus 2. There it is again, written neatly. So the first frame, okay, again, is 2 plus 0. The second frame is 2 plus 2. Now notice these numbers always equal what's in this column anyway. Now if we look at the third frame, we still have those original 2. Then we have those 2 that were added before, and then a new number, or a new number of squares, is added. And if we look at, I'm circling it, and I can say that it's T plus 4. Finally, when we look at the last frame, okay, another set of red squares is added. So I can take the last frame, and say that it's 2 plus 6. So in doing that, you're able to see that how the pattern is growing. And it's basically, you're just doing that by changing the color of the shape pattern, so that you see what you had originally and what is being added. So for this one, for example, those 2 green ones represent what you had originally, and the 2 red ones represent what is being added. If you also notice that it's a little bit of an array, so here's the array here, and here's the array here. Now, try to understand this. If not, please ask. Um, that would help because you can also say that 2 plus 4 is also 2 plus 2 times 2. Okay? So it's important to do that as a necessary step so that you're able to see equations more than one way. Finally, for this lesson, we want to prove that you can draw a graph to represent a pattern rule. So here's my graph and my axes is all set up. If you notice, the frame number is here. So there's T. And so here's the first frame, the second frame, the third frame, etc. And the vertical axis is set up with the pattern rule T times 2. So, there's 2 squares, then there's 4 squares, and then there's 6 squares. So to make my graph, I'm going to grab my pencil tool. I'm going to start to make my little circles. So in the first frame, I knew there were 2. There we go. In the second frame, there were 4. In the third frame, there were 6. In the fourth frame, there were 8. And that's as far as I got with my table of values. Okay, so here are those circles again, much neater so that you can see it. Now, to predict the next number or the output or the number of squares in each frame, the graph is helpful too. So what I can do is I can draw a dotted line that comes out of here. And I know you're thinking that dotted line is terrible, but if I make it neater, I'm able to see what the next term in the pattern is. So here's that line again, and it's much neater. And I can see that to find the next term or the next output number, what I have to do is I have to go, 2 to the right and 2 up. So knowing that, I can go, 2 to the right and 2 up. And I would know that, I could put a dot right there. So 2 to the right and 2 up. And I know by doing that, that the 6th term in the pattern, which wasn't in the original table of values, if I look and I line it up here, that the 6th term in the pattern is 12. Here it is again neater, so the dotted lines represent that you're going 2 to the right and 2 up, 2 to the right and 2 up, so that you're predicting the next number in the pattern. So if I go 2 to the right again and 2 up, I could even do, 2 to the right and 2 up, I could even do the next term for the 7th frame, right? So what I can say, and you have to try to remember this one too, is that this line, if I continue this line, it represents the equation or the pattern rule T times 2. Okay, so I hope you understood that. So in summary, in this lesson, we learned how to predict the next term in a number or shape pattern using 3 different methods. First, you can determine the next term in a pattern by continuing to draw the shape pattern. And so if there's 4 squares in the first frame, and then you can continue to add on those squares in the next frame and in the next frame and so on, and count the squares to see what the next number would be. Secondly, what you can do is you can find a pattern rule or an algebraic equation. And that requires a little bit more thinking, but there is a benefit to that because it is, without a doubt, the most efficient way to determine what the next output is. Finally, you can also construct a graph, and you are expected to know all 3, and you really need to develop a skill to find a pattern rule. So I hope this lesson helped you to understand your work.